Okay, this is the 2020 Higher Level Leaving Cert Maths Paper 2, question 6. So a class group carried out a study of the makes and fuel types of cars in a large car park. It found that 30% of the cars ran on diesel, 70% of these diesel cars were Volkswagen. It found that 60% of the cars ran on petrol, 25% of these were Volkswagen, and 10% of the cars were hybrid electric, 9% of these were Volkswagen. One car selected at random from the car park. Find the probability that it's a Volkswagen. Okay, so it's fairly straightforward. You just need to really just get 70% of 30%, 25% of 60%, 9% of 10%, add them together, and that will give you your probability. Now, just to visualize that, we can do a tree diagram. Now, you don't really have to do this, but if you want to just visualize it, we can do something like this. So we have diesel, petrol, and hybrid, and each diesel car is either going to be a Volkswagen or not a Volkswagen. Similarly with petrol cars, so petrol cars are either going to be a Volkswagen or not a Volkswagen, and the same with the hybrids. So the hybrids can be Volkswagen or not a Volkswagen. Now the outcomes then, the outcomes here will be diesel and Volkswagen, diesel and not Volkswagen, petrol Volkswagen, petrol not Volkswagen, and hybrid Volkswagen and hybrid not Volkswagen. So to work out probabilities here, you can just put the probabilities in here along the branches. So 30% of the cars were diesel, 60% were petrol, and 1% then were hybrid. Of the diesel cars, 70% were Volkswagen, so we put 70% here, so the remaining 30% must be non-Volkswagen. Of the petrol cars, 25% were Volkswagen, so that means 75% were not Volkswagen. And the hybrids then, we had 9% were Volkswagen, so the remaining 0.91 or 91% were not Volkswagen. So to work out the probabilities here, so we're really only interested in Volkswagen cars, so we're going to look at this one, and this one here. So if we work those out, we come up along here, it's going to be 0.3 times 0.7. We want this one here now. So this one is 0.6 times 0.25. And then finally we want this one here. So this is 0.1 times 0.09. We just add those up. So the probability then that a car is, the probability that the car is a Volkswagen, if chosen at random, it's just going to be these three added up. So we multiply those two, add them to these two multiplied, add them to these two multiplied here, and our final probability will be 0.369. And that's it. Now, as I say, it's not necessary to do this in this particular question, this tree diagram, but just gives you an idea how it actually works. Okay, so let's have a look at the next question here. This is part B. The Road Safety Authority has data on driving test pass rates at all its test centres. So in a particular driving test centre, the probability that a person taking the test for the first time will pass is 1/4. All of the test results are independent. In this centre, on a particular day, Joe, along with 5 others, take the test. All 6 are taking the test for the first time. Find the probability that Joe passes the test along with exactly 2 others. So Joe has to pass. So the probability, what we're looking at here, is the probability that Joe passes and 2 others pass. Okay, so this is going to be the probability that Joe passes is going to be 1/4, and just means we multiply here. 2 others pass. So what we're going to do here is look at 5, choose 2. The probability of passing is 1/4, and that's going to be to the power of 2. This here. The probability of failing is going to be 3/4, and that's going to be 5 to the power of 5 minus 2. Okay, so this comes from the formula n choose or. P is the probability of success to the power of or, Q is the probability of failure, and n minus or. So that's the formula I'm using here. Okay, so we've just got to work this out then, and when you do that, it's really just calculator work at this stage. So when you work all of that out, you get 135 over 2048. So the probability that Joe passes and 2 others pass, exactly 2 others pass, is 135 over 2048. Okay, so part 2 then. The overall pass rate for all drivers at another centre is 1/2, where it is their first attempt or a subsequent attempt. On a particular day, n people take the test in this centre. The probability that 2 people or less than 2 people pass the test can be written in the form an squared plus bn plus c divided by 2 to the power of n plus 1. A and b are natural numbers. Find the value of a, the value of b, and the value of c. Okay, so we want to work out the probability that 2 people or less pass the test. 2 people or less, so let's write that out. So we want the probability that 2 people pass, exactly 2 people pass, that's going to be n choose 2. The probability of success is 1/2. We raise that to the power of 2. We're using the same formula that we used in the previous question. And then here it's n minus 2. So it's n choose 2, 1/2 to the power of 2. 1/2 is the probability of success. And this half here is also the probability of failure. And that's the power of n minus 2. Okay, so that's the probability that exactly 2 people will pass. 1 person passed, the probability that 1 person will pass is going to be n choose 1. Again, 1/2 to the power of 1, 1/2 to the power of n minus 1. And then finally, the probability that no one passes is going to be 1/2 to the power of 0 times 1/2 to the power of n minus 0, or just n. So we've got to work all this out, and presumably we'll end up with the expression that we had in the question. So let's work all this out. So n choose 2 can be written as n times n minus 1 divided by 2 times 1, or just 2. 1/2 squared is 1/4, and 1/2 to the power of n minus 2, well, 1 to the power of n minus 2 is just 1, 2 to the power of n minus 2 is 2 to the power of n minus 2. Okay, next one. So we have n choose 1. Well, that's just going to be n over 1, if you like. And then we've got to multiply that by 1/2 to the power of 1, which is 1/2. 1/2 to the power of n minus 1, well, 1 to the power of n minus 1 is just 1, 2 to the power of n minus 1 is 2 to the power of n minus 1. And finally then, n choose 0 is 1, 1/2 to the power of 0 is 1, so we're just left with 1 over 2 to the power of n out here. Okay, so let's deal with all of this. Now, let's take this bit here first. So we will multiply out the top line, so it's n times n minus 1, which is n squared minus n. That's times 1 times 1, so we'll just leave that. And then on the bottom here we have, I'll just do it over here, we have 2 times 4, which is 2 squared, times 2 to the power of n minus 2. So this is the 3 denominators here, here, and here, 3 denominators. So we have 2 to the power of 1, 2 to the power of 2, 2 to the power of n minus 2. So we add all the powers. That'll give us 2 to the power of 1 plus 2 plus n minus 2. That'll give us 1 plus 2, which is 3. 3 minus 2 is 1, so we just get 2 to the power of n plus 1. 2 to the power of n plus 1. So here we end up with 2 to the power of n plus 1. Okay, so let's just do the second one then. So we're going to do this one here. So we have n times 1 on the top, so that's just n. On the bottom we have 1 times 2 times 2 to the power of n minus 1. Now similarly here we've got 2 multiplied by 2 to the power of n minus 1. So this is 2 to the power of 1, so we've got to add the powers. So 1 plus n minus 1, so that's just 2 to the power of n. So down here we end up with 2 to the power of n. And then out here at the end we've got 1 over 2 to the power of n. Okay, so let's just add these three fractions and see what we end up with. So our common denominator here is going to be 2 to the power of n plus 1. So that means the first fraction is just going to remain the same. Now, what about this one here? We've got to divide this into this and see what we end up with. Well, 2 to the power of n plus 1 divided by 2 to the power of n. Subtract the powers. So that gives you 2 to the power of n plus 1 minus n. That just gives you 2 to the power of 1, which is 2. So this divides into this 2 times. So we got to multiply the top by 2. So we get 2n up there. Now what about this one here? It's the same thing again. That divides into this 2 times. In other words, you got to multiply this by 2 to get this. So we got to multiply this by 2. So we end up with 2 on the top there. Okay, so now we have n squared on the top. We have minus 1n plus 2n, so that's just plus n plus 2, and that's all over 2 to the power of n plus 1. Now the question here was to find the values of a, b, and c. We have the 2 to the power of n plus 1 on the bottom, and we have this kind of format on the top. So all we got to do is read off the coefficient of n squared, n, and the term independent of n out here, a, b, and c. So that just means then that a is equal to 1, b is equal to 1, and c is equal to 2. And that's it.